All right, so I guess we'll go ahead and get started. So this is just a little bit about me. My name is Danny Briggs. I am a senior IT analyst with the Greater Victoria Public Library. I'm a longtime virtualization enthusiast, done lots of virtualizing of operating systems and applications in all kinds of different platforms. It's tons of fun. I'm a mentor with HighTechU. Been doing that for about a year and a half, 2 years now, I think. I'm a Realm First Mythic Raider in World of Warcraft, and I know how to pick up a dime with a forklift. just some fun facts about me there. So before we can start talking about Docker, we need just a little bit of background information. This might be a tiny bit boring, but I promise it won't take long, and you're welcome to tune out if you just want to get to the exercises. So we're going to start by thinking about what sort of things power the internet. At the very bottommost level, it's servers. So all of those applications and websites that we use every day, they need somewhere to run. And all of those developers and system administrators need something to kick when things aren't working. But despite their kickability, there is a problem with servers. There's actually a few problems with servers. For starters, they're really not all that efficient. Could you imagine if we had to have a great big physical server for each and every application or service that we wanted to run? Data centers would be a whole lot bigger, and they're already pretty big. So let's assume that you're running one application or one service per server. It would probably run somewhere between 1 to 20% of its total utilization of the server's total utilization. Most of the time, it would be idle if it's not doing anything, and all in all, that's not very efficient at all. If you consider a catalog, for example, it's got probably a web server and it's probably got a database. And that server is probably only doing anything meaningful when a visitor comes to the page. The rest of the time, it's just sitting there wasting power. So we're going to look at, for example, a Dell PowerEdge server. Dell is a manufacturer of all kinds of computer hardware. You're probably familiar with them. So I looked up a relatively modern Dell PowerEdge server, and it can draw up to 4,800 watts. That's 4.8 kilowatts of power. That's enough to run 20 refrigerators. Imagine running 20 refrigerators just to host a catalog. Kind of crazy, right? So you're probably thinking at this point, but if I run 100 blogs on one server, I'm not wasting all that power. And you're absolutely right. But what happens if, say, 99 of those blogs, if one of those blogs decides that it's going to use all the disk space on the server or all the RAM on the server? Suddenly, this issue with one cat blog has taken down 99 other cat blogs. You're going to have a bad time. So one way to solve this problem, how can we solve this problem? There's a couple of different ways, and one of them is virtualization. Virtualization is the process of splitting one physical server into many virtual servers, each with its own independent operating system. This is super cool if you want to do something like, say, run a Linux virtual machine on your Windows desktop, or if you need to run Windows on your MacBook and you don't want to do that whole boot camp thing that they can do. The thing to remember with a VM, though, is that you have to treat it like a physical computer. So that means like it's like think of it like an appliance that you pull up a chair and plug a keyboard into and a mouse and tinker away with it. It's not entirely accurate to say that because you can manage virtual servers or physical servers for that matter with automation tools. But then you have to learn those automation tools and things like that, and it's a whole other kettle of fish. But that's not super important for what we're talking about right now. The neat thing about VMs, though, is that you can take them and spec them out like a physical computer. So if you've got a physical computer that has 8 gigs of RAM and 100 gigs of hard drive space, you can provision a VM on that physical computer that has 4 gigs of RAM and 50 gigs of hard drive space, leaving you with space to run more VMs or run the host operating system. And this is great because it lets you more fully utilize a machine. So if you've got, a dozen applications that are all running idle most of the time, you can spec out a bunch of very small machines and run your individual applications on them, and the server itself will be more fully utilized. The other really nice thing about this is that if one server has an issue, like say the application goes crazy and eats up all the disk space, or it uses up all the RAM or CPU power, then the other VMs that you're running are going to continue to work fine. You've created an environment where that problem is all contained inside that one virtual machine. There are exceptions to this, of course, where like a VM could go crazy and take down the entire host, but if you've provisioned it carefully and correctly, that usually won't happen. Plus, there's all kinds of other good stuff like greater IT efficiencies, reduced operating costs, faster workload deployments, increased application performance, higher server availability, eliminating server sprawl and complexity, blah, blah, blah. These are all like businessy buzzwords coming straight from VMware, a proper virtualization solution provider. So now moving up in the stack a little, what are all of these servers or virtual servers doing? They're running applications or services. So a service, just to get the definition out of the way here, is basically a piece of code or an application that works with other services or other applications to power one sort of super application, which is what the user interacts with. Think about it like, let's consider YouTube, which has a ton of services behind the scene that enable users to watch and like and dislike and comment and post and all these things with their videos. At the end of the day, it's a video hosting provider, but it's got all of these other services and all these other features as well. We can simplify that example by thinking of it as just two services: a front end service and a back end service. But in reality, a complex site probably has a ton of microservices that are doing things like that. So far we've discussed two types of architecture. Running your application and its dependencies in a single server is an example of what's called a monolith. Monolithic architecture is difficult to scale. And a single failure in one of the components can bring the entire system down. So that's an example of running. That's like running your database and your front end service and your back end service all on the same physical machine. If your database goes crazy and eats up all the disk space, then obviously your web service fails as well. Imagine too if you wanted to scale it, like say you're getting a lot of traffic to your site and you need to add more servers or increase the capacity. You would have to provision a new server every time you wanted to increase the service. And that would be madness. That would be really difficult to do. Running virtual machines is a good way to work towards a service-oriented architecture, or SOA. It's important to note here that simply virtualizing your monolith doesn't make it an SOA deployment. SOA means that you split your architecture into independent services. So, for example, you could have a server for your web, your web server and your front end, and you can have a server for your database or your back end, right? And those are two separate machines that are independent from each other. Because of VM templating and how quickly you can deploy a VM compared to deploying a physical server, it makes scaling your environment really, really easy. And the final thing we're going to mention here is what are called microservice architecture, or MSA, which is what we're going to be playing with today with Docker. So in this case, the services are separated from the underlying operating system, and they are usually, but not always, designed to scale. So let's say suddenly our example cat blog is getting a ton of traffic. We can scale it up by adding more microservices and then scale it back down when the traffic returns to normal. It's also possible, whether intentionally or not, to cram your entire monolith into a container. But again, that doesn't make it MSA at all. That just means you've got a monolith running in a container. So when you're designing a microservice architecture, it's important to be considering that from the very beginning and building all of your code and all of your applications to run that way. So that's about it for the history lesson. We're going to finally start talking about Docker. Thank you for bearing with me through that. So what is Docker? So Docker is a tool for running services inside of a container. The really nifty thing about Docker is that thanks to a service called Docker Hub, which is a repository of Docker containers, it's really easy to find containers that you can basically just glue together and base your containers on. So you can think of it kind of like Lego. If you need a database, you can pick your database container, and then you can attach it to your web server container. You can attach like worker containers. You can do all kinds of crazy things with it. It's a very useful technology, so you can do like all kinds of helpful things with this, like containerizing your development environment to make things easier on like your development team, and keeping your development environment in sync with your production environment. And it also looks really flashy on a resume, so that doesn't hurt either. So let's talk about Docker containers versus virtual machines. So remember that a VM has to run an operating system that an administrator has to configure, patch, install, and maintain through its entire lifecycle. By comparison, a container doesn't actually really need an operating system of its own. It uses the operating system installed on the host, which makes them a lot smaller and a lot faster to spin up. So you can spin up a Docker container for like a Linux distribution in a couple of seconds compared to the time it would take to install and configure a Linux distribution in a virtual machine. So I'm just gonna move the mouse over here. I hope you guys can see this. So right at the bottom here in our example, we've got an example of machine virtualization, and that's running on some generic physical infrastructure. And that could be your laptop or desktop. It could be a big, complicated rack of servers, or it could be cloud infrastructure, which is like Azure or AWS or whatever service provider in the cloud. And on top of that infrastructure, you're going to run what's called a hypervisor. A hypervisor is a special scaled-down operating system that is just designed to run virtual machines. VMware ESXi is an example. I can't remember what the Microsoft one is called, or sorry, I can't recall what the AWS one is called. But Microsoft has Hyper-V on your laptops. You can do like VirtualBox, all kinds of stuff like that. And inside of that hypervisor, you're going to define a VM, and on that VM, you're going to install a guest operating system, and then you're going to install the binaries and the libraries that you need to run your application, and then you're going to install your application. You can do that as many times as your hypervisor has resources to support. So you can run as many VMs as your machine is capable of running. On the container side, it's basically the same at the bottom. We're going to have some infrastructure that's responsible for running these containers. And instead of a hypervisor, we're going to run pretty much any operating system. Docker and containers run on all sorts of different operating systems, and you can basically pick your favorite. And on that operating system, we're going to install a container engine. Docker is an example of a container engine. There's also things like FreeBSD jails, OpenVZ, I think, for Linux. There's a whole bunch out there. I can't recall them off the top of my head, but today we're concerned with Docker. And in that Docker container, you're going to have binaries and libraries and applications. You can see the guest OS is the missing piece in the middle here. We don't have to really care about what guest OS our containers are running. In some cases it matters, but in most it doesn't. So this is all a tiny bit confusing, and I like to think in analogies. So imagine it like this. You've got a bunch of friends or services that are renting a house or a physical server together. Sorry, excuse me just a second. My door's blowing open. So sorry about that. So imagine a bunch of friends or services are renting a house or a physical server together. It's pretty great because you've got William the web app and Daryl the database, and they live under the same roof, and they can interact with each other super easily. There's no latency. They don't have to run next door to talk to each other or whatever. They can see each other all the time and work together really well. The problem is that the house is a little bit underutilized. There's only the two of them living in that house, and there's room for 6 other services. There's a bunch of empty bedrooms and space to fit other people. And you've got a problem too if one of the appliances breaks. It impacts both William and Daryl, because now the oven is broken and neither of them can cook. Daryl, as it happens, eats lots of cereal. So when he uses up spoons or RAM for his breakfast cereal, he doesn't always wash them, and it takes William a while to clean a spoon when he needs to use one. I should note here that it's not necessarily that Daryl is a bad roommate, it's just that databases are notoriously bad at freeing up RAM. So now imagine that those friends each have their own apartment or virtual machine. Now, this is great because Daryl and William both have their own space. If Daryl doesn't wash his spoons, it doesn't slow William down at all. And if William's oven breaks, Daryl can still cook. There are still other empty apartments, but they're relatively easy to fill. So if another person wants to move in, Sammy the sysadmin, or building superintendent, has to go to an empty apartment and set everything up for them. However, because the apartments in this case are furnished, there's a lot of configuration that Sammy has to do to get them ready for a new user to move in. It turns out that Daryl and William were committing tax fraud, so it's off to Docker jail for them. The cells are a lot smaller than the apartments, and there's a lot less to maintain. There's no furnishings or operating systems in the cells, so there's nothing really for Sammy the sysadmin to install. And because of the difference in sizes between apartments and jail cells, you can fit way more applications in the same size of building. Quick footnote, you shouldn't do that in real life. Prison overcrowding is a real problem. This is just an example. The troublemakers, William and Daryl, can still do their jobs, but they're restricted from doing anything else. Fun fact here, the FreeBSD operating system has its own containerization technology that's been around for 13 years longer than Docker, and the technology is called jails, which is sort of where I got the idea for the slide. Okay, so that is enough about VMs and jails. We're going to do something fun. So this is where we're going to start with the labs, and just so you guys know the format I'm going to use for these, I think, is I'm going to basically step through the book and show you guys what the lab exercise looks like, which won't take very long. And then we're going to wait for about 5 minutes so you guys can try it yourself if you're so inclined, and then we'll just jump into the next one. It should go pretty quick because they're not very long at all. So the first thing we need to consider is that we're going to need a place to store the Docker containers we're going to build. So we're going to sign up for an account with Docker Hub. You can think of Docker Hub kind of like Git or GitHub, but for Docker containers. Just like Git, Docker stores its containers in what are called repositories, and in these repos, you can separate different versions of your container by tag. So just like with GitHub, you can store your containers in public or private repos. So if a container is private, you have to log in at the command line before you can push or pull it. And we're going to use a service called Play with Docker to, play with Docker without needing to install anything on your local machines. This is great. We can do it all in the browser, and it's so easy to use. It's pretty user-friendly, but it does have a few tiny quirks, and we'll see what those are once we get started. But all in all, it should go pretty smoothly. Every single thing that you need to do with Docker, I shouldn't say that because I'm sure there's a lot of advanced configurations that I haven't considered here, but for today, every single thing that we need to do with Docker, we can do with just a text editor and the Docker command. So bear with me just a second here while I pull up the workbook myself, something I should have done in advance but completely forgot about. All right, let's open up a new window. We'll just drag this over here. So we're going to start by going to hub.docker.com. And I'm already signed in, but I'm going to sign out. Oh, that's lovely. Okay. Hub.docker.com. There we go. That was super weird, but we'll just skip over it. And we're going to hit this sign up button here to sign up for an account. I'm not going to sign up for one because obviously you saw I already had one, but the general process is this. You're going to create a Docker ID, which is like a username, some user, an email address, some user at somewhere.com, and a password, and confirm you're not a robot. And what we're going to, one thing I will mention about this is because of the way the Play with Docker service works, we do have to log into our account here. So if you're one of those people who uses the same password for everything, you shouldn't do that, but I'm not here to judge you. Make sure you do use a unique password for this service in particular, because we don't want your password living on your main password living on some strange virtual machine somewhere. So once that is done, you're going to go to your email and confirm your email address, and once you're confirmed, we can go ahead and sign in. Oops. It always defaults to your email address, which is annoying. dbriggs555. Oops. I have two accounts. One that I made for the example, and my other one as well. So we're just making sure we're logging in with the right one. And now that we're logged in, we can open up a new window. Play with Docker. And we're going to go to labs.play-with-docker.com. Depending on how you, what you're comfortable with, I usually just search, and the first Google result is usually good to go. And we're going to log into the account. And once we're logged in, we're going to click Start. And it's going to take a second to fire up the instance, and here we go. So we've logged in now. We've got our own unique playground that we can use, and we're going to click this Add New Instance button. And it's going to create a node for us. A node is just a very small virtual machine somewhere that's got Docker installed and ready to go for us. So now that we are logged in, we've got our Play with Docker instance ready, let's run our very first container. So we're going to click into the instance here just to make sure we're typing in the right screen. And we're going to run our first Docker command, which is docker run hello-world. And press enter. And it's going to spit out some text for us here. And we'll look at this line by line. So first one is unable to find the image hello world latest locally. And so since it can't find the image locally, it's going to pull it from Docker Hub. And so it does some stuff here. We don't super care about these. This is I think the build hash. No, sorry, this is the build hash. But this doesn't matter all that much. But basically what it's doing here is it's checking the local version if there is one, and then checking the hub to see if there's a newer version. Since there isn't a local version, it just pulls down whatever the latest greatest is. And then this container is doing the one thing that it's supposed to do, which is to spit out a hello world message. And to generate this message, Docker took the following steps. It contacted the Docker daemon. The Docker daemon pulled the hello world image from Docker Hub. The Docker daemon created a new container from that image, which runs the executable that produced the output you're currently reading. And the Docker daemon streamed that output to the Docker client, which it sent to your terminal. Pretty cool. So that's it for the first lab. It's 1:21 right now, so we're gonna wait till about 1:26. And then we'll keep going. Feel free to follow along with your copy of the workbook. And if anyone has any questions, I'm not actually in the stream, but Andrew and Dom are, and they can relay them to me via chat. So please feel free to shout out, if you have any questions or concerns.